Hello everyone, welcome to another lecture of linear regression, and today we will discuss about the cost function, that how could we minimize it, and let's get started. Okay, so let's take a quick revision that what we did in the previous lecture. So what we did actually, that we had a prediction line. Okay, we had actually a prediction line, and we had some data points. We had some data points there. Actually, let me take it this. We had some data points. And what we did there is actually that we named it something, which is this is ground truth. Okay. This is the prediction that our model has made. This is the predicted line. Okay. This is the prediction line. And we talked something about cost function. Okay. If you remember, then we have talked about something known as cost function. What it was actually is that it was nothing but 2 by n. Okay. Sigma from 0. Okay. To n. Okay, into this y hat I minus yi squared, and this is nothing but our cost function. And what cost function is, that it is telling that what is the error, what is the mean of our error, what is the mean of our error. Now if our error is low, our model will be better. We know that if our error is low, model or prediction, okay, whatever say, prediction is better, cause less the error, less the mistake, and higher the efficiency of our uh, model or the work. Suppose, as I give the example of, if you scored good marks from the previous test, then you are actually doing great and you are improving actually. And the best result at the end, that best result, that is actually a reasonable result, that I said that, which was 98.5, which is actually great because you cannot get 100 out of 100. Okay, it is actually in the virtual dream that you're living in it. If you can get it, then yeah. But if you talk about practically, then 98.5 is, actually cool. It's a very good result for us. Now we have to minimize this function. What we are saying minimizing it, what we are actually saying it by minimizing is that we have to, we have to watch who was our boy. Yes, this boy. We have to look to this function that is giving this us this line, that will change the game. If we deal with this, this function, then this will change the game of prediction. Okay, and it will give us the best result. Now, as I talked, who is actually giving the lines? Two parameters, this and this, m and b. These two are giving our line. Okay, if we tweak these parameters, okay, we don't know how to tweak, but if we tweak this parameter, then can we get uh, can we lower our error rate? Yeah, definitely, why not, we can, definitely we can. How will you do it? Now we are moving to machine learning things, and in the machine learning terminologies, in the machine learning terminals, understand it. Okay, the machine learning terminologies, we don't use it m and b. Okay, this is used in the linear functions, or mathematical or actual pure maths. But in the machine learning term, what we use is betas or thetas. Okay, for the sake of getting understanding, betas or thetas, these are nothing but these are variables. Okay, these are variables. Now what we're doing here is that we are using for the b beta 0, and for the m, okay, for the m beta 1, we can use it, it is same. Okay, it is same. So it will be, wait, beta 1 x plus beta 0. Okay, beta 1 x plus beta 0, this is going to our function that we use it. It is nothing but we did nothing, that we used only beta 0 and beta 1 in the place of m and b. Okay, in the place of m and B. Okay. Now we want to minimize it. Okay. Our goal is to minimize it. Now, one more thing here is that I didn't tell you. If uh, if we are using, okay, what we are using, if we are using means, okay, yeah, if we are using squares for making our errors positive, okay, for making our positive, then it is known as mean squared error. Mean squared error, RSE. Oh, sorry, MSE, not RSC. MSE by my mistake. MSE, mean squared error. And if you are using absolute values, absolute, then it is known as mean absolute error. Mean absolute error. Nothing but MAE. But we are using MSE, so that's we will say MSE, and we will use MSE for saying that the squared function. Okay, the cost function we will say MSE. Why? It is actually cost function, but there are different type of cost function. Okay, there are different types of cost function in which we have MSE, MAE, and we have another RMSE. Okay, RMSE, which is nothing but root mean a squared error. Okay, these are nothing. These all are cost functions. These are the types of and another name of so cost function, but these are type of cost functions that will use it. Okay, mean squared error is also a cost function. This also is a cost function. This also is a cost function. And we have to minimize them all, not each, but one of it, because everyone is related. If we are using MSC, then we'll have to minimize the MSC. If we are using RMSC, then we have to minimize the RMSC. Okay. Now, till now, we have got our error. Okay. We have got our error. We have also sum it all. We have also sum it all up. Now, what we will do that we will use, some um, statistical and mathematical stuffs to understand that how will we get how will we lower our value point. Now, as I have said that which values are defining the line, which values are defining our line, this, and what we have wrote this, nothing but beta 1x plus beta 0. Okay, beta 1x plus beta 0. Okay, we're doing it, and these two actually also defining the line. Now we will have to set beta 0 and beta 1 in the way that it will give less error than the previous one. Okay, so what I'm saying here is actually that how did we got our line when we put some value into beta 1 and beta x, beta 0 and beta 1. If we put some new values in the beta 0 and beta 1, we will get different values. Okay, and if you get different value, then we will have a different line for we would have a different line. And if the line and its cost function, which is nothing but mean squared error, RMSE, okay, or RMSC, okay, you could see what RMSE is, root mean squared. If it is low, then these parameters are good. Then the values for these parameters are good. Okay, now how will you find the appropriate values for beta and beta 0? For that, we are getting less error. Okay, for that we are getting less error. Understand me? Okay, open your mind and keep this in your mind that what will be the values that we need to find, and we have to put in beta 0 and beta 1 that will give us the less error. Okay, we have to find it, and that is our goal actually here. Okay, that is our goal actually here, to find actually the values of beta 0 and beta 1. For that we will get less error, and this is our goal. This is that simple, but this is not easy. Okay, this is simple that we have to find the values of beta 1 and beta 0, but this is not actually easy. Now, we have a concept actual also here, but we won't talk it here right now. But suppose that we give some random values to beta 0 and beta 1. Okay, beta 0 and beta 1. Suppose that it could be 0, 1, 2, 3, 4, so on till n. It could be also 0, 1, 2, 3, 4, so on till. Now there would be a point where 1 and 2, okay, 1 and 2 is fitting the model and giving the best result ever could possible. Okay, there will be a point I. Okay, suppose there is a point I in it and I in it also that are giving us the best value. Okay, and for the value we are getting the less error ever. Okay, so our goal is to find that. Our goal is to find that. Okay, now we have to minimize our MSC. Okay, cost function, and we have our two parameters. What are the parameters? Beta 0 and beta 1. We have to lower this error. What the approach we could apply it here that we're getting less error. Okay, we are getting less error. You're getting now. You could say that we can get the values of beta 1 and beta 0 by this also, that y minus beta 1 x. Yeah, we can find it, but this is, it will go into statistics and we don't want it right now. We don't want to get into statistics. Yeah, statistics is important, but we don't get into right now. So what we can do here is actually is that we could use a function that is known as hypothesis function. Hypothesis function is nothing but this. This hypothesis function, I think what we call this is the hypothesis function in which beta 0 plus beta 1x. This is hypothesis function h of x equal to y. This is what we have. Hypothesis function. Now, this is hypothesis function. Now we can use a technique that is called gradient descent. Gradient descent. That will help us to find the best value of the beta 1 and beta 0. Okay. Now we have our hypothesis function. Okay, this is nothing but hypothesis function. Our goal or aim is to minimize the MSE cost function. Okay, cost function, and our superhero, it's nothing but, okay, who is nothing but gradient descent. Okay, gradient descent. And how do we use it? Gradient descent, let's understand. Okay, so what we are doing here actually is, okay, what we are doing here actually is MSC is mean squared error. Okay, now what is mean squared error if you see here actually? Okay, now so we have our hypothesis. Okay, we have our hypothesis function, which is this, and we had some prediction y. Okay, and we had some prediction y. Now there is an actual point which is y. Okay, we know that we have an actual point of y and we want to minimize it. This is our predicted value, and which is nothing but y hat. Okay, which is nothing but y hat, and we have to find the best value. And how we can do it? We can minus it. Okay, and from the hypothesis function, what we'll do that if we want to minimize it, then we can minus it from the hypothesis function. See why we will minimize it from the hypothesis function. Okay, because it is actually the prediction, and prediction is nothing but why what we had y hat, and y hat is actually hypothesis function. And if you minus it from the hypothesis function, then it is actually same that we are we are subtracting from the y hat, which is actually the predicted, you know, the predicted value. We were minusing it from that. Now, if we will, if we see this function, then this function is what? It is nothing but beta 0 plus beta 1 y. We can say that, yeah. Now for what value? Okay, suppose that for a value, we'll squaring it. For value, we got 2. Okay, we got 1.5, we got 1, we got 3. Which is the lowest value? 1. And for the value, if we got 1, then there would be some parameters for the beta 0 and beta 1 that we have got the less value. For that value of beta 1 and beta 0, we would have got the less values. Then what is the values of beta 0 and beta 1? Okay, we should ask this, that what is the value of it. It would be something. It would, I'm not telling you to think, but I'm telling you it would be something. Now we are doing actually is we're defining a function j, which is nothing but our MSC. We could say that beta 0 and beta 1, these are our parameters. Okay, that will we will pass. We do nothing, that we will do this. What this is our? What is this our? Nothing but cost function, man. From the n, okay, because we want to do it n. Now we will do it h of x, which is hypothesis function. Y, I is nothing but a superscript to, to interpreting, if you're interpreting, then, and we have to see this. Okay. Now, if we want to uh, have a graph of it, then which graph can we have? Okay. If you want to see the graphical, then our graph would look like this actually, because it is actually a quadratic equation. Okay, and if it is a quadratic equation, we will get parabola. Okay, which looks something like this. Now there would be a point where our cost function is minimum, the minimist, the minimal minimist. Okay, and this will be a function in which we will be tweaking our betas, in which they will reach here at some point, and it will cross here actually after some time, and we have to find that at which point did we have the lowest, the lowest value of the our cost function. And if we reach to this value, then we will have our the best cost or best model, because we have the lower the error. Now how will we get to this point? Okay, how will we get to this point? Simple, we have to iterate our beta 0 and beta 1 over and over again, and if we do it over and over again, then we will reach it. Then we will reach it to our beta 0 and beta 1. Okay, the our appropriate and the perfect beta 0 and beta 1. For that we could use for the other prediction also. Now we will use something known as calculus, one of the most great thing in maths, that we will use calculus for doing our graded descendant. What does it look like is that, so calculus says nothing, it says that how much change in y if we change x. Okay, it says nothing, that if we have relationship between x and y, then what is the change that is reflected in y if we change x. Okay, and in calculus we say this. Now we could say that we had some earlier beta 0, which would be something. Now we using the concept of calculus, and we are saying that what is the change of, okay, derivatives, what is the change of in the cost function, wait, not the cost function, yeah, in the cost function, actually we could say that it is a cost function, I forgot it, that what is the change happen in the cost function if we change our beta 0, which is nothing but dy by dx. What is that? How much y changes if x changes? If we change 2 from 1 to 2, then there will be change something in the beta, you know, the beta 0, the hypothesis function, and we have to find that specific point where the cost function is minimum and where we will win actually. Okay, now we will see this in the next video, that how will we find this with an example. Okay, we will see this, that how we can use an example to find the best cost function. Now you have got the idea that we have a cost function and we have to minimize it, and what we will use it, we will use it gradient descent for it. And how gradient descent works, it basically works in the principle of calculus, in which it says that how much this cost function changes when we changes our beta 0. Okay, how much beta 0 changes, cost function changes, this changes when we change this value, because there is a parameter in it, and if we change this, then this whole will change. Okay, so now I think that you would have got the point. What actual point of this video? I'm making long videos, but I need you to understand and feel that what I actually want to tell. It will be longer, but I will definitely tell you that what actually happening behind it. Okay, I know I don't need to sometime exaggerate. I sometime actually don't tell what I need to tell, but still I am doing it very slowly and very perfectly, and I'm doing very, in a conscious way, actually to tell you that what actually happening behind it. Okay, and if you have any doubt, you could ask me in the comment, and you could join also our Discord server. You will find more enthusiasts there also. Okay, so thanks for watching till now and giving your valuable time. Thanks everyone. I will meet you in the next video. Bye bye. And all the links are given in the description below. Okay, bye bye.